At APE, we're always trying to cut out waste, especially wasted time, and we lose a ton of hours moving material and supplies around the shop. So today, we're gonna work on a custom solution, see if we can't solve that problem for good. This is American Precision Engineering. We make the stuff that makes the stuff. There's a few types of waste that we have on all of our projects. One of those that we suffer from, as most shops do, is we gotta move stuff around. So the last thing we wanna do is take it, move it from one rack to another rack if we can avoid it. So we came up with this design of a cart made just for a pallet that we're gonna see if we can't just take parts straight from the laser, never even put it onto any rack, so we can go from laser to hardware, to forming, to welding, have that pallet right along on the cart. So we're gonna make this cart real quick out of some drops of sheet metal we have. Gonna be similar to some of our other designs, so see how it works. All right, so here's this cart that we're coming up with. So it's basically a modification of our normal carts where we make this thing. So this is only gonna be made out of 4 pieces of sheet metal. They're very robust carts, very light, but it's sized exactly the size of our standard pallet. And we made it so you could put one kind of the opposite direction on the bottom. So that's sort of an experiment, because normally carts, if they have shelves, people just start storing random stuff. Ideally, this thing can take parts. You can throw parts on top of this thing from the laser, go deburr them, hardware, forming, welding, basically stuff never leaves this cart. So it's just a little experiment we're gonna run out of some scrap sheet metal we have lying around. See how it works. So we're gonna make this from 10 gauge, just regular carbon steel. So we got a first piece of 10 gauge loaded up. We'll go over now, check out Delano over here at his station, getting it all nested. This is our Armada 6K fiber laser that we use to cut just about anything we can fit inside of it. We take our 3D files from SolidWorks and then we unfold those into their flat pattern. And then we use this flat pattern design inside the laser software to nest all these pieces together onto the sheet of material that we're gonna cut it out of. We press go, and at that point we can kind of walk away. The machine's gonna cut all these parts out within a few thousandths of an inch, and we can just let it do the hard work of cutting metal with a beam of light. Here's our first parts coming off. You can see all laser cut out. You see that edge is like perfect. So it's gonna raise up. It's gonna put that next sheet in there now. After all those pieces are cut on the laser, we take them over to the press brake to make all the necessary bends. And while the press brake's quite possibly the simplest machine on earth, it basically just goes up and down, nothing more. But it goes to a very precise location with a lot of force. So you can turn a flat piece of metal into a not flat piece of metal, which not only adds stiffness to the part, but it also starts becoming a 3D component and the start of something new. So each piece gets programmed so that the machine knows where to hold it, what angle to bend the part to. And while this looks really simple, it's a machine that can take a long time to master, but simple parts like this, they're no problem at all. So as long as we did everything right up until this point, these pieces should slide together perfectly.
Oh, okay, I got you.
Next, we're gonna fasten all the pieces together with these here little metal sticks known as blind rivets and this metal stick shooter tool known as a rivet gun. Yes, we could connect these pieces together with weld, but actually using the rivets makes it really easy to get the pieces in the correct position relative to each other without having to have a fixture like we would if we were welding. And rivets are actually surprisingly strong. If you think about it, rivets are what hold an airplane together, so they should be totally fine for holding this cart we have. All right, so we got our cart ready to go. It's all fabbed up. We got the handle installed. We put some PIM nuts on the bottom to hold the casters. And now it's in our shipping queue to head over to powder coat to get all fancied up. So in a few days, we'll have it back ready to test. All right, it's a few weeks into having this cart and it's worked out great for us. You can see over here, we've taken parts from over on the laser. We pull them off the laser, set them right on this cart, move it over the press brake and start forming right off that. We never need a forklift. We never need a pallet jack. The guys have already started asking for more because even on a project like this, sometimes it goes from flat parts to form. We don't have enough space on the pallet anymore, so it'd be nice if we could have two without ever having to put stuff on the ground. But overall, I don't think we're gonna make a whole lot of improvements. We might get rid of that bottom shelf because we're not really using it and it's sort of a magnet for trash and random stuff. So overall, super stoked, gonna be making more of them. If you like this content, subscribe, like it. We're gonna be making more content like this in the future, so hopefully you stick around and check out some more stuff. Agua.